Now we will talk about variation of parameter to solve the particular solution. Okay, variation of parameter, which is VOP, for finding the YP. Okay, and this is more general method to find the particular solution, but it's more difficult to solve. So this is a more general method for finding particular solution of the higher order ODE. Okay, so yn prime plus pn minus yn minus 1 plus dot 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 plus p1 y1 y prime plus p0 y equals some forcing function. And we don't care whether this forcing function is very difficult or not, or very simple or not. For undetermined coefficient, you need some precondition. This forcing function has to be very simple, has to be with a constant coefficient inside this forcing function. That way you can solve using undetermined coefficient. But using variational parameter, it doesn't have that kind of preconditions. Okay, so how to solve? Assume that in order to find the general solution, you need both the homogeneous solution and the particular solution. So we usually solve with the homogeneous solution first. So you assume that for this equations that you already know what is the homogeneous equation, which is YH, with an arbitrary constant inside this homogeneous solution, which is C1 Y1 plus C2 Y2 plus dot 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 plus Cn Yn. And this Y1 to Yn are linear independent solution, right? Then UYP, use variation of parameter, will be U1, which is as function of x, Y1. This Y1, of course, is as function of x as well, plus U2, Y2, plus dot 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 plus UN, Yn. Okay, so you basically, each homogeneous solution, you times a function of x to construct your particular solution format, where U1 will be equals to W1x over Wx, Rx dx. U2 will be W2x over Wx, Rx dx, dot dot dot, until UI will be Wix, Wx, Rx dx. Okay, so you know that this Wx is represents for the Wronski determinant, that Wronski determinant. The Wx, where the Wx is the Wronski determinant, which is determinant of Y1, Y2, dot dot dot, Yn, Y1 prime, Y2 prime, dot dot dot, Yn prime, dot dot dot, Y1 n's prime, Y2 n's prime, Yn n's prime. And since that Y1, Y2 dot dot to Yn, they are the linear independent solutions, so that the Wronski matrix won't be 0. That's why you can put there, it won't be 0, so that it will be validated for this U1 to UI. Okay, that is the Wx. And what is UWIX? The WIX for each term, so W1, W2 to WI, that is the determinant obtained after replacing the S column of Wx with the vector equals to 0 dot 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 2 0 0 dot 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 2 1 transpose. So Wix is also a determinant of a matrices, but these matrices are slightly different as compared to these matrices. For example, for nth column, it will replace this nth column with vector 0 0 until to 1 transpose. So for example, here the Wn, or you can say W1X here for this matrices will be the determinant of 0 0 2 1 y2 y2 prime dot dot y2n dot 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 yn yn prime dot 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 yn n's prime. So that will be the determinant of this matrices after you switching the first column with this transpose vector. Okay, and we will make an examples how to use the variation of parameters to solve the second order linear ODE with a forcing function. Okay.